This time, folks, we're going to talk a little bit about the halos. Now, remember there are all of these different parts of the anatomy of a galaxy. And in the center, there is an inner halo and an outer halo. The entire galaxy is approximately 90,000 light years across. And these inner and outer halos are very, very large structures. The inner halo is about as large as the disk. Now, the disk is about 90,000. The inner halo is not quite that big, but the inner halo has a diameter of about 60,000 light years. The outer halo is huge, 200 to 300 light years across. This outer halo is a very, very large ball of matter that is outside our Milky Way. So let's talk a little bit about each of these. The inner halo is the area that contains those globular clusters. Remember, Harlow Shapley found the globular clusters were located centered around the galactic center. In the inner halo, structures are very, very old. And we can look at those, we can determine that by their chemical composition and the fact that the stars in those areas happen to be very, very old stars. They've been around for a very long time. They're a long way along their life cycle. They're old people. They are not young people in Starland. The inner halo is also very, very hot, about 100,000 degrees Kelvin. That means that there is so much energy, there's so much kinetic energy, there's so much movement and motion in that inner halo that the matter can bump into each other so extensively that it will start to glow. So as we look at pictures of other galaxies, as this chapter unfolds, we're going to find that the inner halo has a tendency, for most galaxies, the inner halo has a tendency to glow. But it doesn't contain an awful lot of matter, contains a small quantity of matter. This inner halo, this glowy area around it, only contains about 2% of the matter of all of the disk itself. Now, the outer halo is the huge structure that is very difficult to see. You have to have very good optics in order to see that. 200,000 to 300,000 light years across. And here's the thing that's wacky, and in the last 50 years has really kind of knocked astronomy on its ear. The outer halo contains 5 to 10 times more matter, more mass, than all of the mass that's in the galactic bulge and disk and globular clusters around it. So what is producing all of this matter way out here in the outer halo of galaxies? This is one of the big hints, big clues about something known as dark matter. And we will spend a lot of time talking about dark matter. What is it? How was it discovered? And the current quest to understand it and at a later time. But astronomers believe that the outer halo of most galaxies are made of this weird and crazy stuff, dark matter. Why is it called dark? It's called dark because, first off, we can't see it. Well, then if we can't see it, how do we know it's there? And we know it's there because it exhibits a force of gravity. So whatever this stuff is out here, it has a gravitational tug on everything around it. And that's the clue. We are about 25, other slides said 25,000. This slide says 28,000. Yeah, we're a ways out from the galactic center. And we are rotating on one of these spiral arms. We are rotating around that galactic center. At what speed? Well, it takes about 250 million years for us to make one complete revolution around the galactic center. So how long is 250 million years? It's a long time. To put it in perspective, the last time we were at this location in our rotation around the center of the galaxy, there was on planet Earth, there was one supercontinent, Pangaea, due to continental drift. Dinosaurs had not evolved and humans had not evolved. So this is before dinosaurs even, that we were at this same spot. If you like geology at all, this was about the time of one of the great dyings between the Permian and Triassic layer. There was a huge extinction. And things like trilobites, crinoids, if you love fossils and stuff like that, this was the period of time where they ruled the earth and they went extinct. So very interesting stuff. What caused that extinction? They believe massive volcanoes, lots of carbon dioxide really changed the climate, weather, and environment. So why are there spiral arms in our galaxy? Well, this is a huge question. This is a huge, huge question because we know they exist. We can see them in other galaxies, but there's a lot of logical reasons they should not be there. First off, how do we know about the spiral arms and their rotation rates? Well, that goes back to our old friend, the Doppler shift. And this is how this works. If we look at certain arms and the light from those arms are blue shifted, that means that those arms are moving towards us. If we see light from other spiral arms and the light is slightly redder or red shifted, that means that those arms are moving away from us. So we know there are arms, we know they are rotating or spinning, and that's due to the Doppler effect. This is how we figured this out. But a long time ago, astronomers asked this question: why, after billions and billions of years of spinning, hasn't the whole spiral bunched up tight? Here's an analogy that I like to use, and that is looking at cream in coffee. If you pour your cream in your coffee and you stir it, how many times do you have to stir it before it is completely mixed? 10 times? I mean, if you did 10 good stirs in your cup of coffee, would it be all one color and even? All right, maybe you're a little crazy and you do 20 times. Well, okay, it would still end up uniform everywhere. It is predicted due to the age of our universe, due to the age of our galaxy, and our galaxy has to be at least as old as the oldest things we can see in it, which is about 8 billion years. If we are spinning once every 250 million years, that means that it should have spun at least 30 times that it has spun around its galactic center in that 8 billion years. I mean, it should have spun a lot. Why isn't it all bunched up tight? Why do these spiral arms still exist? Why does it look like this instead of that? This is the hypothesis of why these spiral arms exist. And the idea is a strange one because there is not a common example I can use to explain this. It's called a spiral density wave. The idea is that there was some sort of large event, a big gravitational event. Where does the spiraling come from in everything in outer space? Conservation of angular momentum, something that started with a little bit of rotation, and then as it sunk down, it spiraled closer and closer and tighter. And what we believe is some large gravitational event exploded, but it didn't just explode straight out like an explosion would explode in all directions outward. It is believed that whatever this was, as it exploded, it was an exploding spiral. It had so much rotation in the beginning that rotation 8 billion years later is still observable. So I think of it like an exploding spiral. And each one of these compressions that were given off by the explosion is trapped in these spiral arms. So it doesn't just go outward, it's kind of exploding outward like that. Very odd, not the sort of thing you see in normal everyday life. But it will explain why there is the most density at the center and there is less density as it radiates outward. So why do we know this or suspect this? In the center of our galaxy, the stars are very, very old. And then in each individual arm, if you look at an arm, the older stars are nearer to the center, and then they get younger, and then they get very young at the beginning. And we think this spiraling density wave pushed individual molecules together, squeezed them together tight enough so that they could start to produce a star. And that's the analogy, and that's what we think has occurred. So what caused these large explosions or spiral density waves? Well, it's got to be a huge gravitational event, something that caused gravity to change quickly. And that would be a gravity wave, okay, a wave like water waves on a pond, but a wrinkle or wave through the fabric of space-time caused by something huge happening. What's huge enough to make that happening? Black holes combining. We know black holes are in the center of galaxies, and if you take two massive black holes and you combine them to make a supermassive black hole, the quantity of gravity they're going to send out into space is going to be humongous. And we think that's what caused these original spiral density waves. All right, that will end that. And next time we're going to talk a little bit about discovery of galaxies.